Okay, so we're going to be talking about the continuity of this function at x equals 1, 2, 3, and 4. And remember, for continuity to happen at a number a, you need these three conditions. You need f of a to exist, you need the limit as x approaches a of f of x to exist, and in this particular condition, don't forget that in order for this one to work, you need the limit as x approaches a from the left to be equal to the limit as x approaches a from the right. And you need both of those left and right limits to be equal as well. And if that works, then the last thing that you need is for the limit as x approaches a of f of x to be equal to f of a. Okay, so let's start with x equals 1. First of all, f of a exists because if you go to 1 and check it on the diagram, f of 1 equals 1, so f of 1 exists. Okay, the limit as x approaches a of f of x. Does it exist? So the limit as x approaches 1 of f of x. As x approaches 1 from the left, that does exist. The limit as x approaches 1 from the left is equal to 1. However, the limit as x approaches 1 from the right, that's approaching 2. The left and right limits both exist, but they don't agree. So the limit as x approaches 1 of f of x does not exist. So continuity fails on that condition. And also, is the limit as x approaches 1 of f of x equal to f of 1? Well, it doesn't exist, so it can't be equal. So this one, x equals 1, this fails our test for continuity. Okay, how about x equals 2? So if we look at x equals 2, does f of 2 exist? Yes, if we plug 2 into this function, we would get that f of 2 equals 2. How about the limit as x approaches 2 of f of x? Does that exist? Well, checking the left and the right limit. As x approaches 2 from the left, the limit is 1. As x approaches 2 from the right, the limit is 1. So far, we have this one works and this one works. The left and right limits both agree and they both exist. But does the limit as x approach 1 of f of x, is it equal to f of a? No. F of a is 2, but the limit as x approaches a of f of x is 1. So that does not work. So it's not continuous at 2. How about at 3, at x equals 3? So first of all, does f of 3 exist? Yes, it does. If we plug 3 into this function, we would get, I don't know, 1.5 or something. So f of 3 does exist. The limit as x approaches 3 of f of x, the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right, they're both going to the same thing. So it does exist, and they both agree. And is the limit as x approaches 3 of f of x equal to f of 3? Yes, it is. So each of these all work. So this one is continuous. Remember, so far we have that this one is not, and that's a weird looking check sign. That one is. On to x equals 4. The limit as x approaches 4 of f of x. On to x equals 4. Does f of 4 exist? No, it doesn't. We have a vertical asymptote there, so that's not going to work. Does the limit as x approach 4 of f of x exist? No, even from the left it's negative infinity and positive infinity, so they don't even agree on the same infinity. Definitely not. And is the limit equal to f of a? No, because f of a doesn't exist, the limit doesn't exist, none of this works.